Right, that should be good. Let me make sure we're live. Sweet, all right. Looks like we're live, so welcome. This is another Voltage developer workshop. This is the second one I'm doing, and I'm Austin. I'm the developer relations engineer here at Voltage, and so yeah, I'm deciding to do these workshops monthly, and this is kind of a good opportunity for me to go and solidify some, I guess, basic skills, basic examples, and different things that people want to do, and just kind of solidify it into example, into tutorial, and do some learning, and then get some actionable working code at the end. And of course, just be interacting with and developing on Lightning and on Bitcoin. So those are some of my favorite things. So it's great to have this chance to kind of take a concept and then spend about an hour on it. And yeah, so today we're going to be talking about development nodes. And I had trouble naming this workshop, and I think that we even need to work on our framing in the space around this whole concept. But it's like, how do you develop on Bitcoin? How do you develop on Lightning? There's a lot of intermediary steps that come into play versus maybe if you're just developing full stack applications or something like that. And a lot of this just has to do with the environment. It has to do with the testing environment that you're working within. And what Voltage has with MutinyNet, what MutinyNet created, which is essentially a test network for developers, has made it way easier, and in my opinion, just way different to develop on Bitcoin and Lightning. I have a way easier, way more enjoyable time now as I'm building apps, whether they're big or whether they're simple examples, because a lot of the difficulty and the friction of getting spun up is now easier than ever with these kinds of development node options. So that was why I chose this topic for a workshop, and hopefully you'll walk away with just kind of an easier workflow for getting spun up and starting to make things happen on a Bitcoin node or a Lightning node for developing whatever you're developing. We're going to be focusing on applications for this workshop, but of course it can apply widely as well. Some more preamble. I'm trying to think. There's been a lot of change in the space as well when it comes to test networks. A lot of other chains, they just have a test net, and this test net just works. And a lot of the wallets and applications are integrated with it. So it's very easy to test and be interoperable. And that journey for Bitcoin has definitely not been the same. We have a lot of different test networks and feature-specific test networks that are out there. And so, yeah, I think that MutinyNet is something that a lot of, especially the newer developers and application developers, can unify around, and it has great tooling to work with. And so I think you'll feel pretty empowered once we get through this stuff. So cool, I think that's enough context up front here. We can start to go through the slides here, and we'll start with some theory and then get into some practice with some code and build a simple application. Sweet, so here are the links that will be relevant. The link to the slides is also at the top on my overlay here. So yeah, these slides are going to contain, all of the text, but also all of the code that I'm going to be walking through, and I'll actually build the project along with you step by step, going through the slides just like you would. But of course, if you just want to jump to the completed project and have a simple template, there is a link to the GitHub right here with the completed project and a replit. And I think I'll be building the project today on replit. We also have documentation for MutinyNet, our developer sandbox, so that's good to check out as well. And just for context, we are going to be using React for building our simple wallet app. Cool. So there are the links. Get into these slides if you want to follow along live, and of course the link and the recording of this video and all of that will be posted after the fact. All right. So overview, what are we going to be getting into. We're going to talk, first of all, about developing on Bitcoin and Lightning. We're going to talk about the difficulties developing on Bitcoin and Lightning. We're going to talk a little bit about the different Bitcoin networks that I alluded to already. We're going to have an intro to MutinyNet Signet, which is what we'll be using for our development node. And I'm going to show you how to set up free development nodes on Voltage for both Bitcoin Core and LND. This is such a huge value prop that not enough people are taking advantage of. So I'm excited to show you that. And then also we're going to be spinning up these development nodes. I'm actually not going to spin them up live. I have MutinyNet nodes already set aside, and it takes around 15 to 20 minutes for them to spin up sometimes. So I'm just going to kind of run with mine. But it's a very simple process, so we'll walk through that. And then finally, we're going to build a simple wallet application to kind of leverage and showcase development nodes. And the goal of that is just going to be a project to get you started where you're connected to these different node interfaces for Bitcoin Core and for LND. You know how to make the basic calls. You just have a boilerplate to really get started, because that's actually a lot of the difficulty of just developing applications on Bitcoin or Lightning, and we'll definitely touch on that. Sweet. So let's get into it. Okay, so developing on Bitcoin and Lightning. So I guess an overview. I tried to gather my thoughts here. And this sounds intimidating and a little bearish, but this is a little bit of what it takes to develop on Bitcoin and Lightning if you're developing apps or something like that. So it requires basic knowledge of Bitcoin and Lightning protocol. You kind of know what you're talking about when you're talking about addresses or different address types, or with Lightning, we're talking about invoices, pre-images, channels, liquidity. These are concepts you want to be familiar with. You don't need to be a protocol expert, but you need to be definitely familiar with the protocol and able to answer your own questions as they come up. Understanding of Bitcoin and Lightning node infrastructure. There's a lot to say there. These are like servers on steroids oftentimes, and so there's a lot of consideration that goes into that. Knowledge about networking and interfacing with peer-to-peer networks. This especially applies to Lightning. It's very common to get a decent way through a wallet application or something like that on Lightning. Maybe it's your first one, and running into these crazy networking errors, errors connecting with other peers or opening channels with other peers. And it really requires some kind of understanding, some kind of foundational knowledge. Understanding of Bitcoin's various test networks. You at least need to be onboarded onto one, or maybe you're just developing in mainnet. Sometimes, that's how it goes. I've done that plenty of times. Understanding of RPC, gRPC, and ZMQ interfaces. These are very common and powerful, important interfaces in Bitcoin and Lightning. gRPC being very common in Lightning, and then RPC and ZMQ are both interfaces that are shipped with Bitcoin Core. And finally, for Lightning, understanding different node implementations and their trade-offs, right? So are you running LND? Are you running Core Lightning, Eclair, LDK? So these are, and they all have their own trade-offs. They all have their own considerations depending on what you're doing. So these are all a big bunch of, requirements, really, and overhead. And a lot of this actually can be made much easier and abstracted away with a good Bitcoin and Lightning development environment, in my opinion. And so biggest pain points summarized. Infrastructure and interface. So we just talked about a bunch of, requirements, difficulties here. And I would be able to summarize a lot of those into these main pain points of the pain point of infrastructure and interface. So infrastructure just being the node implementation, hosting the node, connecting your Lightning node to your Bitcoin Core node, getting it deployed, getting the certificates right, all of this consideration of just getting a server, a node up and running. So that's infrastructure. Interface, of course, just being talking to your node, having an effective interface that works within your application or whatever you're doing. Are you cool with just synchronous calls? Do you need something asynchronous? Do you need streaming data? And so getting tapped into that interface, knowing which methods to use, feeling comfortable with them, that is a big hurdle. And kind of once you're past these 2 points, infrastructure and interface, you're really feeling pretty good. You're making pretty good progress, because then you're just talking directly to your node, right? And that's where the real magic happens. And so, yeah, definitely a goal of this workshop is to get you to that point as soon as possible. Okay, so spinning up a node for development can be hard. Running SIGNet, testnet, reg test on a node, that can be hard, especially your first time. Interfacing with your node can be hard, potentially with these requirements that I talked about. Testing payments or interactions between multiple nodes can be very hard. Testing development nodes and features across time is hard. So yeah, I mean, there's kind of the getting the infrastructure up and running, and then there's actually being able to interact with it in the way that you would expect would be happening in production or on mainnet. And just that alone can be very difficult to simulate and get in a development environment. Okay, so a lot of bearishness, a lot of pain here up front. Look at these emo Bitcoin and Lightning developers. They're feeling it. But luckily, things are getting better year by year. And so we're going to get into that. But first, let's talk about the different Bitcoin networks. And so I've kind of alluded to this, but in case you don't know, there's basically 4 different kinds of Bitcoin networks, or main kinds. We've got mainnet, testnet, reg test, and SIGNet. And so mainnet is the main Bitcoin network where actual transactions occur. They have real economic value. I mean, yeah, it's the real thing. Testnet is an alternative Bitcoin blockchain used for testing. Testnet coins are separate and distinct from actual Bitcoins and are never supposed to have any value. This allows application developers or Bitcoin testers to experiment without having to use real Bitcoins, worry about breaking the main Bitcoin chain. So testnet, that makes sense. All the other cryptocurrencies, lots of projects have testnets, but we go deeper still. There's reg test, which stands for regression test mode. This is a local testing environment where developers can control block generation and create an almost instant private blockchain for testing purposes. So this is an easy path to take. It's a very good path to take, reg test, but doesn't always have what you need for testing out your application logic. Finally, there's SIGNet, a relatively newer network that is like testnet but with a twist. SIGNet is a test network that uses signed blocks, which means it has more reliable block times compared to testnet. So in the SIGNet, we're not simulating the proof of work in the mining in the traditional way. There's just a number of signers, and they just sign every block at a completely set interval. Okay, so what should you use? Why do you care about this? So this is just some context, some high-level context, so you feel like you walk away understanding these different Bitcoin networks and why you might want to look into one or the other. I like to summarize it like this. In short, mainnet is global and real. You're on a global network, it is real value. Testnet is also global. It's a global network, but it is fake. There is no value. Reg test, on the other hand, is local and fake. There's no value, but it's only locally, it's a local network on your machine. If you have a server or some kind of service worker in the cloud or something like that, it won't be able to talk to your reg test node because your reg test node is only on localhost, right? And then SIGNet is also global and fake. And of course, the only difference between SIGNet and testnet is this simulation of mining and proof of work on testnet versus on SIGNet where, the signers just sign the blocks at a set interval. Sweet. Okay, so that's our high-level understanding of the different Bitcoin networks. And so let's get into MutinyNet. Enter MutinyNet. This is a cool GIF I made. This is from the Voltage MutinyNet video. And so MutinyNet is a SIGNet, and it is the SIGNet that Voltage has really embraced. It's a great network for developers. It was built specifically for supporting mainly application development, with strong focus on Lightning as well as, even though it is a test network for Bitcoin, actually. Yeah, so MutinyNet was released on Voltage, I think about 8 months ago, something like that. And let's talk more about it. So what is MutinyNet, or why MutinyNet? This is a snippet from the Mutiny team, their blog post from when they launched MutinyNet. So there are several key reasons why we decided to create MutinyNet. So simplified testing infrastructure. We wanted a simple test network with all the infrastructure already up and running to make it easier for us to test new features and enhancements. Faster block times. The default Signet block time of 10 minutes can slow down testing, so we've cut this down to 30 seconds, allowing for more efficient testing of new features and bug fixes. The most obvious win here is we can have a channel confirmed much more quickly. Yeah, so this is really great for Lightning stuff where you may be opening, closing channels, and needing to do all of these kinds of actions that take block time that you can't force forward. So having that 30-second interval is very, very powerful here. Another powerful point, testing over time. A Lightning channel isn't just a one-shot thing. It's a long-term, stateful, romantic relationship between two nodes. Plenty can go wrong, and by creating long-lived Lightning channels between Mutiny Wallet and other nodes, a MutinyNet, we can make sure it's battle-hardened. Custom signets are cool. Everyone is setting up their own signets these days. We want to join the party and add our own block time twist. And yeah, that's, I guess, some other important context. Like, a lot more signets have been emerging lately, and a lot of it is just developers that want their own solution. But I feel that MutinyNet is a good, just happy default, a really good default solution for developers needing kind of test network. Cool, so that's MutinyNet. How MutinyNet works on Voltage. So free accounts get one free MutinyNet Lightning node and one free MutinyNet Bitcoin node. This is such a huge value in my eyes. Like, you can just be an anon Bitcoin Lightning dev, and you need that development node that is hosted on good infrastructure, that is always online, that is readily available, has an easy interface for you to plug into. That is exactly what this is. I mean, it removes almost all of the friction of getting spun up and starting to develop on Bitcoin and Lightning. And once your application is in a good state on MutinyNet, you can just switch over a few environment variables and you're on mainnet, right? And everything is going to work the same, all the same considerations, almost. And so, yeah, I mean, it's an amazing value. If you're on a starter account, which is our lowest paid account, I believe you get 3 MutinyNet Lightning nodes, 3 MutinyNet Bitcoin nodes. It might only be 2 Bitcoin nodes, I'm not sure. But yeah, I mean, that's the full gambit right there. That's the full Bitcoin interface at your fingertips, the full LND interface at your fingertips, completely for free. So MutinyNet and Voltage, awesome value. And so I guess I'll show you how to do that next. But first, actually, we're going to talk about useful MutinyNet tools. There's a faucet for MutinyNet. We're actually going to check this out in a minute. I have this open right here. There's also a mempool instance, a block explorer for MutinyNet at mutinynet.com. So these are really awesome tools that kind of like, it's everything, at least for me, it's everything I need outside of my local environment and my node to test absolutely everything, try absolutely everything out. And there's MutinyNet as a network, so there's other peers, there's other nodes that you can connect to, open channels to on this network, etc. And you can actually find them through the block explorer as well. Okay, cool. So walkthrough on how to spin up MutinyNet nodes. So on the left, this is our Lightning node interface. This is our Bitcoin Core node interface, both of them for MutinyNet, you can see from the tag there. And so this is what you can get spun up completely for free. Okay, so no, actually, I'm going to jump over here. So I'm already logged into my dashboard here on Voltage, but you can create a free account on Voltage with just an email and claim your MutinyNet node. So let's go to my team. And so first of all, so in this project, we're going to be leveraging both a Bitcoin Core node and a Lightning node. The Lightning node is definitely more important for the project and for the beginning of the project. So if you want to follow along live, spin it up live, start with Lightning here. And basically, so what we would do is we would click on creating a new Lightning node. We would say new node right here, and you'll end up on this page. And you just need to go over to MutinyNet. You'll see that free tag. Continue. And then just like normal with our nodes, you'll put in a node name and you'll put in a node password, which will actually encrypt your node in our cloud servers. So once you submit that, your node will start spinning up. Should take about 15-20 minutes tops before it's ready, and you'll have a pretty nice interface after that. And Bitcoin Core is very similar here. You can go new node, full node, and then MutinyNet. Great, so I'm gonna jump over to my Lightning node here on MutinyNet. Austin test. Let's see if I remember my password. Cool. There we go. So something that is a little bit different here. Our applications are not enabled for MutinyNet at this time, so that is one limitation. But something we do have is a faucet built right into the UI here. So with this button, you can get on-chain MutinyNet coins right away. Let's get some. Let's get 100K sats, receive on-chain. That'll update pretty quick. We can see my confirmed on-chain is 24 million right now, so that should update. We actually might not see that update. Let's do a million. A million. And since these block times are 30 seconds, right? I mean, yeah, look at that. That was about 3 seconds. All of these are always going to confirm very quickly. And of course, we can open a channel here of a certain amount and then kind of push an amount to that channel as well to make it instantly balanced. So that's pretty nice. But to go in a little more depth, you might go to faucet.mutinynet.com. And from here, you can receive, let's see, on-chain, have a Bolt 11 invoice paid. You can get channels. We've got Nosh Wallet Connect. You can peer. They have an LNURL endpoint. We've got Fedimint. So there's Cashumint. There's a ton of options here. So almost everything you're doing with Lightning, you can interact with the MutinyNet faucet here. So that's really nice. This can kind of just be another peer that you can check yourself against to make sure that you're actually working, you're actually interoperable. And of course, I already pointed out the MutinyNet mempool instance here. And this is great. Something you might do is go to the Lightning Explorer and you might find some other peers here that you just open up MutinyNet channels to. Okay, great. So it's pretty easy. There's not much to show with setting up these nodes. I mean, it's just a few clicks away and then a few minutes away after that. But definitely reach out to me if you have any questions about this process or just, doing something with your node. Okay, so I think that was about all of the theory around this workshop. I'm trying to think if there's anything else I should call out before we get into our project. Yeah, I mean, not much else. I guess one consideration it's definitely a limitation, definitely important to note. On Bitcoin Core, we do have the wallet API is disabled. So even though it's MutinyNet, there's not real coins on it. The actual wallet API in our Bitcoin Core deployments are all shut down because basically, Voltage is not a custodian. We don't want to store keys on our server. So when people deploy Bitcoin nodes, you can have the full node, but we are not going to let you push keys onto our servers, right? And use the wallet API in that node. But all of the other APIs are fully open. But yeah, that's definitely a limitation and consideration for some of the Bitcoin development stuff. But yeah, I mean, let's just go ahead and get into the workshop here. So we're going to build a basic wallet app that is connected to both our MutinyNet Lightning node and Bitcoin node. Sweet. So this should be pretty cool. Okay, so you can basically either follow along locally or on Replit. The process will be almost exactly the same. It's just a little bit different getting spun up. So if you want to follow along locally, you'll spin up a new Vite app. You can call it MutinyNet Workshop, and just be sure to have that flag for template React. And then getting started on Replit, we can create a new Replit and choose the React JavaScript template. So I'm going to do that. I have Replit open right here. And I'm going to create React JavaScript. And I'll call it MutinyNet Workshop. And mine is private. Yours doesn't have to be private at all. We are going to be dealing with some environment variables, but for one, it's for a node that doesn't have real money. And for two, we are actually going to be using Replit's secrets environment here. Otherwise, you, of course, if you're local, we make a .env and you'll use environment variables. So that should be all fine and good. So we have our brand new Vite React app right here. Go into app.jsx. Let's just run it. See if it runs. Okay, sweet. We see something. So that's a good start. Okay, so spin up the app. That is done. Next, we want to install dependencies and configure environment variables for LND. Okay. So first, we're going to run npm i axios-d. This is the one library we're going to use. And then I'll jump back over here and we'll put in our environment variables. So I'll go to shell. We'll say npm i axios-d. Okay. Too high severity vulnerability. So that's okay. This isn't my machine. We'll just rough it. Okay, so now we're going to have a Vite macaroon and a Vite LND host. And these are going to be two other environment variables. So we have Vite LND host. Oops. Okay, and now I'm actually going to grab this from my node here, from my Lightning node. So I can grab the API endpoint. This is going to be my LND node's host name. So I'll put this in right here, add secret. And then we'll have Vite _ macaroon. And for this, we actually want to get our admin macaroon, right? And so if you don't know macaroons, these are just our permission tokens for being able to talk to our node. And the admin macaroon is the full permissions. That gives you permissions to send payments, to drain your wallets, all of that. So, excuse me. So normally you want to be very careful with this, but, you know, not real money. And even either way, we're putting it in secret, so should be good. Okay, Vite macaroon is in there, add secret. Beautiful. Okay, and then of course, if you're doing this locally, you'll just create a .env file, add these variables, just like we did. Otherwise, you're in secrets. Cool. Okay, now we're going to update our app.jsx. This is going to be our first little bit of code here. So as I said, I'm going to be following along step by step with you. So I'm just going to go in here. I'm going to copy all of this, and we'll jump over to here. I'm going to move this tab inside of here, so it's a little bit easier to jump back and forth. Okay, there we go. So update app.jsx with our basic app structure. And let's see in the web view. Cool. Connected Alice pub key 1 2 3 4 5 6 7. This is fake data, but let's walk through the basic structure, because this is a basic structure that's basically going to continue as we add more features. So we have our app function, and we are setting state for info. This is going to be our L&D node info. And we have a function right here for fetching info. And this is going to try to set the info. So right now we're just hard coding this to start. So that should work. Of course, if anything does not work in this function, we will catch the error. And this use effect will make sure that fetch info will run every time our app renders. So this sets the info, and then when the info is available, when it's in state, we will actually render it. We will render the alias and the pub key. Cool. So that's our hard code example. That is working. So let's get in and start talking to our node next. So next we're going to create a lib/lnd.js for housing our LND API calls. So let me copy this code, and I will, of course, walk through it. So in source here, I'm going to make a new folder in source. It's going to be a lib, add a file, lnd.js. And I'll paste in what we have here. Cool, so what is happening here? We are using Axios, which is just a library for making HTTP requests. We're importing Axios. We're grabbing our environment variables, right, our macaroon and our host, and we're creating a new Axios instance that we're calling LND. So this instance has a base URL of our host at port 8080. Okay, so this is just the REST interface for every node, right? If you have the host name, that port is almost always going to be 8080. So we know that's going to be the base URL. We include headers to have the content type of JSON, and then gRPC metadata macaroon is macaroon, right? So this is us kind of passing our authentication to our node as we make a request, so that our node knows that, you know, we're allowed to make the request. Easy enough. So that's our generic instance of LND. And we can use this instance for multiple different calls. And so this first one we have here is for getting info. So fetch general information about the LND node. So we can call lnd.get at the v1 get info endpoint. And that is all defined in the LND API docs. This has got to be one of my most visited websites, I swear. If you go into the LND API docs, go into Lightning service. These are most of the methods that you're going to be using, that you're going to be looking for. Here is get info. We have super detailed documentation and examples for the different interfaces, different languages. So these are great docs. So definitely look into these if you have any questions about the methods I'm using. But yeah, these are just going to be the most basic kind of LND API calls. Okay, so we have our lnd.js, our basic one in place. Now let's update this, our app component, to actually use real data from our Lightning node. We'll see if that works. So app.jsx, I'm just going to paste all of this in. Okay, so now we have this import for get info from lib lnd. And in our fetch info function, we now actually fetched the info. We have to await it because it's asynchronous. We're console logging it, and then we're setting it to info, and then rendering it all the same. So let's restart our server, and let's see what happens. Cool. That is my pub key. That is my alias. So it looks like we're connected. Let's go ahead and open up a new tab here, because I like to do that. Oh, so bright. I should have made it dark mode, but we're going to do raw HTML, no styles this time. It's just feeling inspired. Cool, so here's our full get info that we're console logging. We can see there's a lot more information here. But yeah, that's very nice. That was pretty easy to get connected. Okay, next up. Fetching balances. So a new method for fetching balances from the API in lnd.js. So I'm going to go in LND, and I'll just put this below get info. Cool, easy enough. And since we already made this LND instance, we just get to keep reusing it. It's very simple to kind of keep iterating on our code and keep it pretty clean. Okay, so that's in place. Next, we are going to add this to our app component. This is basically going to be the flow of the workshop. We're just going to go back and forth for the most part between these two files. Okay, so this is the update of app.jsx. It's pretty big. Let's get this all and then look over it. Oh, of course. So not only are we rendering the balances here, but we are actually updating app.jsx to pull the balances as well. So let's definitely walk through this code nice and clearly. So I can just paste over this whole thing. And let's shove this to the side. Cool. So get info, we are now getting balances. We have two new pieces of state here, one for the lightning balance, one for the inbound. And then we have our fetch balances function. So this gets the balance, and then we set the lightning balance to the correct properties. This is our local balance, and it's just the sat value and then the remote balance and the sat value, right? So that's what's our actual balance that we control as that local, and then the inbound that we don't control, that is referred to as remote. And then this is the polling logic. So before, we just had something like, yeah, basically like this. Like it just ran fetch info every single time we rendered. But now we have a polling interval. Cool, so we're creating this new poll interval with set interval, and it's at every 5,000 milliseconds. And so what happens is on render, fetch info gets run, our poll interval starts, and then fetch balances gets run. But then after 5 seconds, since our poll interval started, fetch balances will once again run every 5 seconds. And then when we return, we clean up the interval, and so it kind of just restarts like that and runs every 5 seconds. Finally, we added a section below here for if we have lightning balance and inbound, we simply just show it below. Awesome. So that is here. I actually have 0 balance. But don't worry, we will fix that. We'll fix that pretty quickly. Let's actually fix it right now, because I'm right here on my dashboard. I can just click on this beautiful orange button. Give me a 10 million sat channel, push me 25%. That sounds great. It looks like I had channels, but they're all inactive right now, so I don't know what happened there. There we go. We have a pending channel. Let's actually look at our app, because this will update in real time. Or it should, if we go to network here, we should be calling channels every, about every 5 seconds. Oh, that's the... Okay, so we see we have a pending open balance right here, but it's not quite confirmed. We'll see it confirm here in a second. Let me zoom way in. Need a few blocks of confirmation, it looks like. Yeah, still pending. One thing we could do is we could track our transaction in the mempool instance right here. But, you know, I thought it would be pretty fast. Okay, there we go. There we go. It updated. We now have a balance of a large amount. What is that? 55 million sats, or just under 5 million sats. Cool. And then we have a whole bunch of inbound. Awesome. Great. So that balances is set up and working, and it is polling as well. Okay. So now we're going to add a method for creating an invoice from the API in L&D. So I'll click into this. And we'll add this new method right below get balances, just like before. Create invoice. Cool. So this is, once again, we're posting to V1 invoices with the value of an amount. And that amount is getting passed to the function. And we just return response.data. Okay, so now we're going to update app.jsx to enable the invoice creation. So I have these ... dots here. This is kind of my attempt to fit this code in and hopefully make it clear that we're only kind of updating the pieces between these sections. But here's how I'm going to do it. I'm going to click into here, and I'm just going to grab all of these pieces of state first. Go into app.jsx. Let's go ahead and stop this because my computer's running a little slow. And I'll update these. Cool. And then we're going to have an added handle create invoice function right here. And we'll move that over. And I'll put it right here below fetch balances. And finally, we'll have our added bit of JSX here that we're going to render. And I'll put this right here at the bottom. So we have info, lightning balance, and then this renders when info is available, because really we just need to make sure that our node is online and connected to, and then we should be able to create an invoice. Okay, so let me run this again, and we'll test it out. Okay, so I've got this create invoice form. I'll jump over here again. Sweet, let's make an invoice. Let's make a 21 sat invoice. Create invoice is not defined. Okay, we forgot to add our import. So after get balances, I'll do comma, what was it, create invoice. Okay, simple mistake. Let's clear this and try that again. Sweet, here's a payment request. That LNTBS, that's how we know we're on Signet. Okay, so now to test, I can actually go to the MutinyNet faucet and I can have them pay this invoice. So pay attention to my balance here. It ends in 56. We should add 21 to that. So let's go over here and we'll paste this in. Strike me now. Paid the invoice. Here's your proof. Okay. I'll trust my own node. That will be my proof. And we see here we incremented up to 77 at the end. So that seemed to work. Cool. So we can create invoices. Those invoices appear to be payable on the Mutiny network. So that is positive. No real bugs so far. That's pretty good. Okay. So we have enabled invoice creation. We know there's one thing left to do. A method for paying an invoice from the API in lnd.js. Okay, so before we put this in, one thing I'll point out. So this is our request to pay an invoice. So it's going to, channels/transactions. But our body that we're passing this request, we're passing the payment request, and also this fee limit. This fee limit is fixed to 1,000 sats. There's different ways that you can set these fees, but this is just something I want to include to point out. You should set this to prevent getting fee siphoned or fee sniped. This is definitely something that can happen when paying invoices. So if you're ever paying invoices programmatically or something like that, set a fee limit so you don't get drained. You don't get brain drained. Okay, cool. We'll copy that and we'll add this into L&D. Just keep going down. Okay. And then we're going to update our app.jsx next. And this is going to be a very similar process. I'm going to grab the state updates first, or the use state slices. We'll put that right here. I'll be sure to import pay invoice. We will have a function in app.jsx. Okay, this is handle pay invoice. And I'll just drop this right down below the create invoice. Save that and format it. Cool, and so this is just calling the pay invoice function with a payment request. That will be passed through a form. And then if we have the payment pre-image, we know it was successful. So we set a payment response and say the payment was successful. Here's the pre-image. Otherwise, if we didn't get that pre-image, we're going to show a payment error. Cool. So there will be one more piece here of JSX to have a form kind of similar to the create invoice form. So we'll copy that, drop it right below here. I'll save to format it. Cool. So once again, if we have info, then we're ready to pay an invoice. We simply put in a payment request, and then a payment response will be rendered. Seems pretty simple. Let's give it a whirl. Okay, but now where do we get a payment request? I actually forgot to put this link. I'm going to put this link into the slides, actually, because this is another useful link. But since MutinyNet Faucet has an LNURL endpoint, we can actually request invoices from them anytime. So get invoices to pay. We'll have this super ugly URL. Okay, cool. So this is basically just the LNURL pay endpoint for MutinyNet, and you pass an amount query parameter here, and this amount is denoted in or denominated in millisats. So be sure whatever sat amount you want, just multiply 1,000 times it. So this is 1,000, so this should get us a 1 sat invoice. So boom, here it is. Invoice. So let's go see if our wallet can pay it. Pay invoice and payment successful. Here is the pre-image. Very nice. Okay. So we are paying invoices. We're returning our sats to the faucet, doing our due diligence. Awesome. Okay, so that's a lot of the Lightning stuff, or that's definitely the basics for Lightning stuff here. But I want to show you how to interface with your Bitcoin Core node as well. So we're going to have just one call, or I guess a few different calls, to get some basic stats from our Bitcoin Core node. And so yeah, what we need to do that is put in some more environment variables, put in some more secrets. And these are all things that you can find on the connect page on your Bitcoin Core instance. So let me show you what that looks like. I'll go back to Voltage over here, and I'm going to go to my MutinyNet Bitcoin Core instance. And it looks like we are running. And so I can go to the connect page. And from the connect page here, we get our RPC host. This will be important. And then we can create a new RPC user with a username and password. And so I already have a user named Austin. And so I'll just go ahead and use that, but I'll grab my host right here. And so our first environment variable is going to be Vite RPC host. So I'll put that into my replit here. Vite RPC host. Okay, great. Next, we're going to have Vite RPC user. And I already know this is Austin. And then Vite RPC password. Okay, and that should be it. Should be able to talk to our Bitcoin node now. And so next we're going to create a lib/bitcoin.js and add fetch and fetch. That's a typo. I would never have a typo. And fetch some info from Bitcoin Core. So let me copy this code. There's actually 2 slides of this code. We'll copy it over and then we'll read through it real carefully. So inside a lib, I'll make a new file, bitcoin.js. Paste this in. And we'll go next slide to paste this in. Okay, awesome. So let's talk through this. So once again, we're importing Axios for our requests. We're grabbing all of our environment variables here, our user password, the host. And because I know this workshop was for MutinyNet, I know for a fact that the port is going to be the MutinyNet RPC port, which is 38332. And then we create another Axios instance. And here we're actually, so we're using our RPC credentials, but of course we're making HTTP requests to our Bitcoin Core nodes. So don't get those conflated. It's very easy to. But yeah, all the same, we have a base URL, which is just the RPC host at the port. And then we have auth that we pass in, username and password. Yeah, and then just one header. And so this is where we make our RPC call. And so we're posting to Bitcoin Core. Yeah, so we're using, okay, this is where it's confusing. I should have explained this earlier, I'm sorry. So we're hitting the HTTP interface for Bitcoin Core with RPC methods. So that's where you don't want to get mixed up. So we're interacting with that HTTP interface. We're passing it different methods. So this make RPC call is just a generic function where we're going to pass a method and we're going to pass optional params for that method. So we simply just hit the Bitcoin JSON RPC and then we return the result. And if there's any error, we catch it and log it. And from there, with that make RPC call created and then the Bitcoin Core Axios instance created, we can just make RPC call for get block count, get difficulty, get mempool info, right? So this would be just like those command line calls, but it takes a little more code to get to. Sweet. So we're going to get some basic stats here, the block count, the difficulty, the mempool info. And then we have a function which just calls all of these in a promise.all, and it just returns them in an object. right? So all we're doing here is we're just setting up the interface to talk to our Bitcoin Core node. And from there, we can just write these super easy two-liner functions to call these RPC methods and keep them pretty organized. So that's our little Bitcoin interface. Let's now plug it into the app component and see what the output is, see if this is working. So updated app.jsx to display Bitcoin stats and fetch them continuously with the polling function. That's right. So we're actually going to plug this into the polling function as well. So just like before, I'm going to start by grabbing these state variables. And we'll replace that in app.jsx first. And then I want to add the import for get Bitcoin Core stats. Sweet. Auto completed for me at lib/Bitcoin. That looks right. Okay, and then we'll have a function here in app. For getting those stats and then setting the Bitcoin Core stats state. I'll put it down here at the bottom. Cool. Just calls the function, console logs it, and sets it. Pretty simple. And then we're going to update our polling function. And we're going to update this JSX. I'm just going to copy this JSX here because I know I can update the polling function from memory. We can do that because we know what we want it to do. So I'll put this right here. Cool. So if we have the Bitcoin Core stats, we display the block height, network difficulty, mempool size in bytes and in transactions. Okay, and then the polling function. And so all we want to do here is sort of fetching balances, and I want to fetch Bitcoin Core stats as well. So these are what gets called only the first time, but then every 5 seconds, I also want to fetch the Bitcoin Core stats. Cool. So I think that should be running. Let's refresh. Uh-oh, I see red. What do we got here? Error, fetching Bitcoin Core stats, Axios error. Unsupported protocol defined. Okay, let's check our work here. Might have got something mixed up. Okay, so let's check VIRPC user, VIRPC password, VIRPC host. That all looks correct. Let me make a new user here. I might have got my credentials mixed up or something. And this will take a second. When you add a new user, of course, you got to restart your instance. But let's look at the reference code. Let's see if we missed something up here. Oh, wait, that's not the reference code. This is the reference code. Get Bitcoin Core stats. Yep, that all looks the same. Yep, looks pretty similar. Let's see what we got going here. Okay, that restarted, or did it restart? There we go, running. Okay, and now I'm going to update my user. And then I'll update my password. Let's try that again. There we go. Beautiful. We got our Bitcoin Core stats. Wowzers. Okay, well, I guess I either had the credentials wrong for the user, or it's possible, I think we restarted our server, but yeah, sometimes when you add environment variables, you have to restart, so it could have been that as well. But awesome, so we are now polling our Lightning balance. We're polling Bitcoin Core node. We can create and pay invoices. We have some tools here to interface with and kind of check ourselves and not be in our own world. And we wrote some pretty simple interfaces here. I mean, we have what is this? A 200-line app. And we just have bitcoin.js and lnd.js. And these are just these generic interfaces for talking to your Bitcoin node, for talking to your Lightning node, with some generic examples, just waiting to be built on. And best of all, this node, you can have this node yourself in about 15 minutes for free on Voltage. So the barrier to entry, it is dissolving, it's disappearing. This is easier than ever. I mean, what I used to have to show people to build their first Lightning app, it was almost sad. But this workflow is better than ever. So I feel freaking awesome about it. Okay, so we got our wallet working in about, I mean, what is it, 5:02. So we been working on that for about 30 minutes. Not too bad. We're talking to our Lightning node. We're talking to our core node. Feeling pretty good. It's beautiful. No CSS either. Didn't fall victim to CSS this time. Okay, so this is our app. Cool. So that was this month's workshop, I guess. Definitely encourage you to check out the slides and the finished projects if you weren't able to follow along live here, which I totally understand. And just check out the Voltage dev community. We have a Discord here that you can join. You should check out our Replit where there's more examples and templates. And please just hit me up with any questions, any ideas you have. If you are building on Lightning, you want to build on Lightning. If you're interested in our MutinyNet nodes, anything like that, hit me up. I'm on X, that's my email. I'm on Nostr as well. And so, yeah, happy Thursday, and thanks for joining me for this workshop. So cheers, and